We have added and we've subtracted radicals. Now we're going to add in multiply and divide. So your essential question is, how do I perform arithmetic on radicals? My learning intention, I'm learning to perform arithmetic with radicals. For your warm-up, you have 4 radical expressions to simplify. Can you do that on your own? Please pause the video and see if you know what to do. Well, I do hope you tried. If you notice, the radicand is the same. If the radicands are the same, that means we just add the coefficients. The coefficients are 3 and 4. So this becomes 3 plus 4 followed by the square root of 7. 3 plus 4 is 7. This is 7 square root of 7. Does it make any difference if we're subtracting? No. The radicands are still the same. So we simply take 3 minus 4, square root of 7, which gives me negative 1 square root of 7. Do I need the negative 1? No. This is simply the opposite of the square root of 7, and we're done. Now when you're multiplying, it doesn't matter if the radicands are different. So let's look at the first one. You multiply the numbers together and then you multiply the radicands together. So this is 3 times 4, square root of 7 times 7. Squaring and square rooting undo each other. So this is 3 times 4 times 7. 3 times 4 is 12 times 7. 10 times 7 is 70. 2 times 7 is 14. 70 plus 14 is 84. Now for the last one. If I'm looking, I'm thinking, ooh, this doesn't look good. They both have C there, but one has a 27 and one has a 48. My first question is, are they simplified? If you said no, you would be correct. If we're looking at simplifying the square root of 27, we're doing that ladder division. 27 is divisible by 3, I get 9. 9 is divisible by 3, I get 3. 3 is prime, 1, and I'm done. So this is the So I've got one pair of 3s I can bring out. And this becomes 3 square root of 3c. What about 48? If I'm looking at 48, I can divide it by 2, I get 24. I can divide it by 2, I get 12. Divide by 2 again, I get 6. Divide by 6 by 2, I get 3. 3's prime. Divide by 3, 1, and I'm done. Once again, I'm looking. I've got a pair of 2's, and I've got a second pair of 2's. 2 times 2 is 4. So this is 4 square root of 3c. I've got that 3 remaining here. It comes back up underneath. Now, I finally have the same radicand. And I simply have to add those two numbers up front. 3 plus 4, square root of 3c. 3 plus 4 is 7. Square root of 3c, and I'm done. On the next one, if we're looking, we cannot leave that radical in the denominator. So we are going to multiply by a funny looking one. We're going to multiply top and bottom by the square root of 15. So this becomes 15 square root of 5 times 15 over 3 times 15. Squaring and square rooting undo each other. Okay, now what? Well, I'm going to start simplifying now because I want my life to be a little bit easier. I've got 15. 15 divided by 15 is 1. So this becomes the square root of 15 times 5 is 75 over 3. Am I done yet? No. Can I simplify? Can I simplify that square root of 75? Well, yeah. So if I'm looking at 75, I can divide it by 3, and I get 25. Divide it by 5, I get 5. Divide it by 5, I get 1, and I'm done. This time I have a pair of 5s to bring out, and then I'll have the square root of 3. So this becomes 5 square root of 3 over 3. And I'm done. Still a lot of making sure we've simplified our radicals. For the last one, I'm looking and I'm thinking, 18 and 27 need to be simplified first. But I can always look, and I've got 8 divided by 4. I'm going to go ahead and get rid of that because this is going to become 1 and this will be 2. So I'm going to start by having 2 square root of 18 over the square root of 27. Now I've got to simplify the square root of 18 and I've got to simplify the square root of 27. The factors of 18, divided by 2 I get 9, divided by 3 I get 3, divided by 3 I get 1. I've got a pair of 2's, a pair of 3's. So this becomes 2 times 3 square root of 2. All of this is over. Same thing with 27. 27, we'll divide by 3, I get 9. Divided by 3, I get 3. Divided by 3, I get 1. I've got a pair of 3's to bring out. This becomes 3 square root of 3. Okay, once again, I'm going to look and think. I've got a 3 in my numerator, a 3 in my denominator. 3 divided by 3 is 1. That cancels out. 2 square root of 2 over the square root of 3. Still not done. I can't have that radical in my denominator. What is that funny looking one I'm going to multiply by? The square root of 3 over the square root of 3. Squaring and square rooting cancel each other out, so I've simply got 3 at the bottom. 2, then the square root of 2 times the square root of 3. 2 times 3 is 6. And I am done. Not particularly hard, but there's a lot of thought processes. You've got to go from one to the next to the next. Do them in order, or you'll not get the correct answer. If you have questions, back it up and look at it again. What happens if we happen to have a radical square root of a? Does it matter? No. We still have to simplify by multiplying top and bottom by the square root of a over the square root of a. This is considered a single term. I have to distribute the square root of a. So I'm going to have a on the bottom, but I'm going to distribute to both of these. So the square root of a times the square root of a plus the square root of a times the square root of b. Now what? Well, this will cancel out. That squaring and square rooting undo each other, so this is a plus square root of ab, all of it over a. Now, if you wanted to, you could separate this, but what we have is perfectly fine. If you wanted to separate it, you would have the a plus the square root of ab, both of them divided by a, and you would have 1 plus the square root of ab over a. Either way works. Both of them are equally good, so you can have the 1 over here, or you can leave it as the fraction here. Okay, can you do the next one on your own? Pause the video and see if you can do it on your own. Well, I do hope you tried. The first thing I'm going to do, I know that I can simplify because 8 goes into 16 twice. So I'm going to have the square root of 12, and then I'm going to have 2 times the square root of 6. Not quite done yet because I've got to multiply by the square root of 6 over the square root of 6. And I end up with the square root of 12 times 6 over 2 times 6. Now I left it, we didn't simplify here, and we could have, but I decided to leave it in this form so we could think again. We know that 12 is 2 times 6. So if I'm thinking logically, this would be 2 times 6 times 6 over 12. Squaring and square rooting undo each other. That means I can pull a 6 to the front. It becomes 6 square root of 2 over 12. Am I done yet? No. 6 will go evenly into 12, so this becomes a 1, this becomes a 2, and our final answer is the square root of 2 over 2. And you're done. Oh, what a mess, what a mess. All those square roots, and 2 of the 3 are not simplified. So let's simplify the square root of 20 first. We know that 20 is divisible by 2. I get 10 Divide by 2, I get 5. Divide by 5, I get 1. So the square root of 20 has a pair of 2's. And this is 2 square root of 5. Okay, what about the square root of 75? If I'm looking at 75, I can divide it by 3, I get 25. We've already done this one. Divide it by 5, I get 5. Divided by 5, I get 1. 75 divided by 3 gives me 25. 25 divided by 5 gives me 5. 5 is prime. 5 divided by 5 is 1. I've got a pair of 5s and then a 3. So I'm looking at 7 square root of 75 is equal to 5 square times 7 times 5 times the square root of 3, which is equal to 35 square root of 3. Okay, we have to distribute. We've got to multiply both terms inside my parenthesis by what's outside. Two square root of 5 times 4 square root of 5 plus 2 square root of 5 times 35 square root of 3. Two times 4 square root of 5 times the square root of 5 is 5, so it's 2 times 4 times 5, plus, I can't combine those the same way. This is 2 times 35 square root of 5 times 3. We're almost done. 2 times 4 is 8. 8 times 5 is 40. 2 times 35 is 70. Square root of 5 times 3 is 15. And that is our answer. Okay, on the last one. You remember the box division from a long time ago. It's time to use it again. Okay, so 7, and this is 8 square root of 11. 3, negative 3 square root of 11. 7 times 3. 7 times 3 is 21. 3 times 8 square root of 11 is 24 square root of 11. Negative 3 square root of 11 times 7 is negative 21 square root of 11. Okay, now the square roots here are going to cancel each other out. Because I've got 8 times negative 24, that gives 8 times negative 3 is negative 24, and then the square root of 11 times the square root of 11 is 11. What is 24 times 11? $264. Positive times negative is a negative 264. We still have to combine on that diagonal. So I've got 24 square root of 11 minus 21 square root of 11 is 3 square root of 11. 21 plus negative 264 is negative 243. And we're done. You know you're successful when you can perform arithmetic on radicals and simplify them. So, if I've got the square root of 11 times the square root of 11, that is simply 11. Hopefully this helped you out with simplifying when you've got the radical, when you have that radical in your denominator.